Hello RMIT. The assignment 1 of the second semester deals with reading of the sales and salesperson XML files, parsing them, and displaying the resulting data in a form control. In this video, we will go over the parsing technique offered in the exercise. Let's note that VB.NET has a special library called System.xml that deals with parsing of XML documents. However, this assignment calls for parsing XML document manually. This is done for demonstration purpose because XML document is so well structured that the process of parsing is well illustrated. Recall that the characters making up an XML document are divided into markup and content, which may be distinguished by the application of simple syntactic rules. The data is identified using tags, which are identifiers enclosed in angular brackets. XML tags act like field names. For example, here, the salesperson ID SP008 is enclosed between start and end tag. As you can see, this XML document contains sales records. Each sales record is composed of several columns, such as sale ID, sale date, customer ID, paid, salesperson ID, and payment type. The task of this exercise is to collect all the content, place it into a temporary storage structure, deliver it to a form, and display it in the form control. How do we parse data? Let's say we need to parse the content of sale ID field. What would we do manually? We would place the cursor at the beginning of the sale ID content and copy all the characters of the content string. Programmatically, we do the same. First, we find the position of the sale ID tag. Obviously, each sales record is going to have this tag. But since we start from the first record, we need to find the first occurrence of this tag. In this case, it is equal to 8. Subsequently, we use this number plus the length of the start tag as our starting position for copying. Considering that the length of the sale ID tag is equal to 9, the start copying position is equal to 17. Then we find the first occurrence of the end tag, which in this case is 23. The number of characters to copy is then calculated by subtracting the starting position of the end tag and the ending position of the start tag. In this case, it's 23 minus 17 equal to 6. Thus, to copy the content of the sale ID, the program should copy 6 characters starting from the position 17. All positions are determined by applying the function index_of. This function has 2 parameters, search string and start search position. In the current example, the search string would be sale ID and the starting position is 0. The end tag string is /sale ID. The program starts searching from the position 18. This is because we already know that there is no end tag before the position 17. To copy the data, the program uses the substring function. This function also has 2 parameters, the position where copy starts and the number of characters to copy. In the example, it would be substring 17.6. Another important consideration is providing the ability for the program to copy many occurrences of the same data type. The example of such provision would be extracting the second instance of the sale ID. In order to achieve this, we need to place the starting position of the index_of method to the end of the end tag. Once the first occurrence of a sale ID has been read, the program can move the file pointer to the end of the end tag. Since the length of the end tag is equal to 10, the starting position of the next sale ID would be 34. Then, in order to extract the next sale ID, we just need to repeat the process described above. The function you see on the screen does just that. As parameters, it receives the content of XML document and start and end tags. The function returns the information as a list of strings. Inside the function, we declare the following local variables: a list of strings to store the stripped values, the start and end tag positions, the integer storing the position where search starts, the number of characters to strip, the integer storing the position where stripping starts, and the actual stripped value. The function starts searching the document from position 0. The next line determines the first position of the start tag. After that, the program sets up a loop that runs while a start tag position is not equal to 0. Such condition happens when there is no data of the searchable type remains in the file. The first line inside the loop searches the position of the end tag. Then it advances to the start stripping position, which is determined as start tag position plus the length of the start tag. The next line determines the number of characters to strip. Then the program uses substring function to determine the stripped value and stores it in the array list. The next important step is to recalculate the new start search position as end tag position plus 1. This ensures that when the program searches for the next start tag, it skips all the region that has already been searched. Once this is done, the program can already start the entire stripping cycle over and assign the position of start tag. Only it is not 0 as before, but the new position is determined by searching the next occurrence of the start tag. The function then returns the array list containing the collected data. Note that in this case, the type of the collected data is known. It is string, which means that a better choice for a return array would be a list of strings rather than an array list. Let's see how it works on the form side. First, we read the XML file into a string, then populate the list of strings with sale IDs. For the sale ID case, the tags should be sale ID and /sale ID. After that, we insert each string from the list of strings into a list box. I hope this was helpful. Thanks for listening.